Okay, here we go. Sound check. Yep, working good. Okay, it says f is continuous. When I read the clue f is continuous, what I always think is I might need that clue, I might not. So I don't forget about it, but I don't dwell on it. I keep reading. F is twice differentiable. We already talked about what that meant. So we can find f prime. We can also find f double prime. It says f prime of 3 must equal 2. F prime of 3 must equal 2. Hands up. Who knows what that means in English? Half the test is just translating from English to math and back and forth. So what does it mean to say that f prime of 3 equals 2? Let's go Lincoln Pay.
Where x is 3 on our chart, f prime is going to equal 2.
Perfect. So if I were making a table, 2 points if your hand was raised. And I were listing the values of f prime, I'd say when I get to x equal 3, whatever f is, the slope of f at that moment will be 2. That's what they're telling you. The rate of change of f will be 2. Questions? I don't know how that helps me, so I keep reading. How do I translate? Oh, I'm just going to tell you. F double prime is less than 0. That brings me right to Danica's chart right away. And I notice that, hey, if f double prime is negative, that means, so f double prime is negative, that's telling me that all the slopes of f have to be going down. The values of the slopes of f must be decreasing. So far I know one thing. I know the slope of f at x equal 3 is 2. But if I had more items in this list, these numbers right here would have to be decreasing. That's what they're telling me by telling me that f double prime is negative. Because f double prime is the slope of f prime. So if the slope of f prime is negative, that means f prime itself must be decreasing. And if you had a graph, it means the shape of f would have to be concave down. Question? Please,
What's the difference between a closed interval and an open interval?
awesome. 2 more. So closed interval means you start examining the xy pairs precisely at x equal 2, and you keep examining them until you get to precisely x equal 4. So that's a closed interval. Open interval means you start examining just barely after x equal 2, kind of like limits, Kai. We'd start looking at x equal a little more than 2. And we would stop just barely before 4. Something like that.
Okay.
Good enough? 2 more. Anybody else? Okay. All right. Which of the following could be values of f? So we're trying to figure out which of those can be f. And we really only have those 2 clues. We know that one value of f prime is 2. Oops, wrong button. We know that one value of f prime is 2. Come on. And we also know that the slopes of f, which are the values of f prime, must be decreasing. Anybody have an idea? I would not call this an easy problem at all. Christian?
So if we know that f prime is 2 and 2 is positive, so does that mean that, actually, I don't know what I was thinking.
You're good. 2 more points, so keep thinking. Anybody else? Please, Josie.
So, since we only have those 2 clues, if we look at the tables, wouldn't we know that if we're looking at something that's concave down, it should start off really small and get really big to the middle, and then like have less of a jump in between 3 and 4? So we just look for like the smallest jump between 3 and 4 and the biggest jump between 2 and 3?
So I'm going to say back what Josie just said. 2 points for Josie. Look. she said if we look at the tables, we're not really paying attention to the fact that these values are getting bigger. We're paying attention to how those values change, which means we're paying attention to the slope. So we're going to find the secant slope or average slope from here to here. So just say it as a class. How much did y change from here to here? Say it. 2.5. You cannot forget to check the x. I've seen them trap students by changing, here x changes by 1, but I've seen cases where x changed by 5. If you don't pay attention to that, they'll mislead you. So we know the secant slope or average rate of change for this interval is going to be, it's going up, so it's 2.5 over 1. It's going up. So the slope of f is said that badly. The values of f are increasing, which makes the slope of f in this region positive, for sure. We check the next one. Hands up. What's the average rate of change on that interval? Hands up. What's the average rate of change on that interval? There we go. Trying to get somebody new. Let's go, Davis.
1.5.
So that one's 1.5 over 1. 2 points if you knew. Okay, we were supposed to identify a situation where the slopes of f are decreasing. Please raise your hand if you can tell me whether or not we have found a situation where the slopes of f are decreasing. Hands up. We found a situation where the slopes of f are decreasing. Pretty good. Let's go, Kate.
Yeah, they are.
Say it louder, Kate.
They are decreasing.
They are. We found that the average rate of change, which means the average slope of f, is going from 2.5 to 1.5. The slopes of f are definitely decreasing. That matches the clue they gave us that f double prime is supposed to be negative. That does work. 2 points if you knew that. Questions, anybody? Annalise had a question earlier. You're good? Yeah, take a shot. Anybody else? Okay, here's the problem. Hands up. What are happening to the slopes here? Hands up. Hands up. Hands up. What's happening to the values of the slopes of function b? What is happening to the values of the slopes of function b? Let's go, Lizzie.
They're increasing.
So what's the slope from here to here, Lizzie?
2.5.
Over?
Is 2 decreasing.
Over 1.
Over 1.
And then this one is?
Over 1.
So are these slopes increasing or decreasing?
They're decreasing.
Those are also decreasing. Okay, 2 points if you knew that. So far A works, so does B. They both have slopes that are decreasing. Okay, questions? Please, Josie.
But wouldn't we know that A is still more correct because it's still following that concave down where it has like, it's getting a decreasing slope at a larger rate than that one?
2 more. The rate doesn't really matter. This is concave down as much as, like this is as much concave down as this is.
Sure.
I suppose you could think of it as more concave down, but there's nothing that reflects that we're looking for that. Good question. Anybody else? Hands up. How about C? Hands up. Does C work? Hands up. Does C work? Looking for hands. For somebody new. Does C work? Almost every Ellie.
Yeah, it's decreasing.
The average rate of change or secant slope of item C also shows that those average rates of change are decreasing. How many new? 2 more. How about this one, D? Hands up. How about D? Let's go, Paisley.
It's staying the same.
Here the average rates of change are constant. So this one's for sure wrong. How many knew that? 2 more. So that one's wrong for sure. And this one over here, they increase, so that's wrong. So we got 3 choices. Anybody have a question about anything? Want to talk about anything? Okay, here's how we sort it out. It is related to what Josie was saying. We have not used this clue at all. We've only used this clue, that f double prime was negative, so the slopes of f, which are f prime, have to decrease. That's all we've used. We've got to use this clue somewhere. F prime of 3 has a value that is exactly equal to 2. Here's how we use that. I got to get a new space on the board here so it'll show up in the video. Okay, you need to remember that we've got this pattern, and this pattern. And I'm going to show you a new screen. So moving over here. Okay, the values of f are increasing. They're doing so in a concave down manner. That means they look like this. So here's f, and exaggerating it, f is concave down. Okay, you have it on your paper. Raise your hand, please. For item A, the average rate of change or secant slope of f from here to here, just say it out loud. What was the value? Say it. 2.5. Okay, the clue said that the tangent slope at x equal 3, right here, had a value of exactly 2. So tangent slope would look like this. The tangent slope would be something like this. Tangent slope. So that tangent slope is supposed to have a value of 2. I'm going to do one that's wrong. I'm going to do item B. For item B, it went 2.5 and then 2. So the secant slope over here was 2. Okay, we just hit something that's impossible. You cannot have the yellow line have the same slope as the purple line and still have a curve. It doesn't work. So B is wrong.
Can you say that again?
Yep. So I know from item B that the secant slope from the first point here, which was 2 comma, you have the packet, what's the 2 comma what?
2,4.
For item B, right? Good. When we get to 3, we're at 3 comma what?
Or wait, sorry, 2 comma 2.5.
No worries. So this is 2 comma 2.5.
And then it goes to 3.5.
There we go. And then on item B, this one's what, Josie?
Which one?
4.7. I got it. You're good. Thank you. Everybody good? So the secant slope right here is 2.5. We know the other secant slope is 2 up here. This secant slope. But they gave us a clue that said f prime at an x value of 3 has a value of 2. That means the tangent slope of this graph called f at this dot must be 2. You can't draw a curve that is concave down and have the yellow slope be the same as the purple slope.
But it's not the same as the green slope either.
Different than the green is fine. Like, in fact, the slopes of f are supposed to be decreasing, right?
Yes.
This slope of f is 2.5. This slope of f is 2. The next slope we encounter must be less than 2.
Oh, okay. Yes.
Must
I
be
get it
less
now.
than 2. Please, thank you.
Can you go back to the page with all the charts,
Yep.
or tables? When you see that the slope between 2 and 3 is 2.5 and the slope between 3 and 4 is 1.5, can you assume that it's just between those two?
You can say that if the slopes of f are always decreasing, the slope in between's got to be somewhere in between.
So you can rule those two out just by looking.
By that same reason, yes. Good job, you guys. Correct answer is A.